Hello everyone, welcome back to EC11 classes. So, as in our last class, we have discussed about node analysis, and we have seen how we can apply node analysis for solving any circuits. So today we are going to discuss a topic on node analysis, which we might find in our circuits, and which makes the node analysis slightly difficult. So the concept that we are going to discuss is supernode. So we are going to discuss how supernode analysis is done. So what is a supernode? That is should be our first question. So nodes that are connected to each other by a voltage source, but not to the reference node by a path of the voltage sources, form a supernode. That means suppose if you have 2 points, these are our two nodes. Suppose this is node 1 and this is node 2. So we have suppose a voltage source in between, and any one of these two nodes are not reference node. Then this form a supernode. So the logic behind supernode is, suppose in this case, let me consider a circuit itself. So suppose this is our circuit, and we are going to solve this one for our analysis. So for the other branches there is no issues because we can directly determine the values, but but in this case, for this two directions, so as per our previous discussion or as per our previous knowledge, what we can write here is, this is voltage suppose V1, this is suppose voltage V2. So in this direction the value should be V1 minus V2 divided by the resistance, but as you can see there are no resistance present here. So if there is no resistance, then it should be 0, because because whenever there is no resistance and there is a short circuit part, so it has a resistance 0. So if we put it here 0, this becomes indeterminate. So in that case we cannot solve this circuit using our normal concept that we have about node analysis. So that is why this type of nodes which share a voltage source in between them without any other resistances is called as a supernode. Okay, so now let us consider a supernode, consider a circuit which contains a supernode, and see how we can solve the problem. So now as you can see here, this is a circuit. We have to determine the voltages in the circuit. So we have how many nodes? As we can see here, we have total, this is one node, this is second, this is third, and this is our fourth node, right? So in order to solve this, we have 4 nodes, we will be having 4 equation, and we will be having 4 unknowns. But in this case, as you can see, this is a voltage source and there is no other resistance in this whole branch, right? So that means this forms a supernode. Okay, so first let us write down the equations in the other two nodes where we can directly write down the values. So for node 1, what will be our equation? So this will be plus 6, then plus it will be V1 divided by 10, right? Then plus, okay, let us name this as V1, V2, V3, and this is a V4. So next will be V1 on the top branch, so it will be V1 minus V4 divided by 6, right? Then we have another branch which is V1 minus V2 divided by 5. Okay, so this is our one equation. Then for the fourth node, so for node 4, now here if you see the value of V4 is directly, we can get it from here, it is 40 volts, right? Because the voltage drop across these 2 points is nothing but 40 volts. So we can directly write down here V4 equals to 40 volt. Now here also, as you can see, this is a voltage source which is lying between two nodes, but this is not a super node. Why it is not a supernode? Because one of the node is a reference node. So if it is a reference node, then we can directly write down the value, because the voltage across this point is 0, the voltage across this point will be V4, so the value is 40 volts. So we have two equations from this circuit. Now next issue will be when we are going to write down equation here, because we cannot write down the equation for these two nodes. So how to solve for supernode? For always supernode, like in case of a super mesh, here also we have to write in place of these two equations which we have lost in that. For that, what we have to do is we are going to write down one KCL equation and one KVL equation. So what will be the KCL equation? KCL equation is nothing but we will be considering these two nodes as a single node, and then we will be writing the equation. So that means we will be having 4 currents, first, second, this is third, this is our fourth. So let us write down the equation. So it will be V2 minus V1 divided by 5 for this branch Ix. Then next one is plus. So next one is plus V2 divided by 20. So node 2 is done. Then we plus V3 minus V4 divided by 2. Then plus V3 divided by 15. 1 second, equals to 0. So this is our KCL equation. Okay. Now next will be KVL equation. So KVL equation we will be writing in this mesh where we have the supernode. Okay. So now if we write down the KVL equation, so first we have to have a direction, right? So for a direction, so let us consider this is our direction. So in this direction, what we can have here is the voltage drop across this point is V3, right? The voltage across this point is V2, and this is our 5Ix. Okay. So what will be the equation? The equations will start from, suppose let us consider this point. So we have V3 here moving from positive to negative. Then V2 we have, so V2 will be plus. Then we have moving from minus to plus, so this will be positive. So 5Ix equals to 0, right? So minus V3 plus V2 plus 5 equals to 0. So this is our KVL equation. So now in place of this Ix, we have to write down the value. So what is our Ix? Ix is this current, so which is nothing but V2 minus V1 divided by 5. So minus V3, or directly we can write V3 equals to V2 plus 5 into Ix is V2 minus V1 divided by 5, right? So this comes out to be 2V2 minus V1. Okay. So V3 equals to this much. So we have one equation, second equation, and this is our third equation. Three equation, three unknown, so we can easily solve now, right? So after solving, we will get V1 as 10 volts, V2 as 20 volts, V3 as 30 volts, and V4 we have already found. V4 is 40 volts, right? So these are the nodal voltages. Okay. So this is as simple as that. So in case of our supernode, what we have to do? We have to first identify the supernode, then we have to write down two equations, because we have lost two equations due to a supernode. So those two equations will be one equation across the outer two nodes, considering them as a one node or single node. We will be writing down the KCL equation, and then we will be writing a KVL equation in the mesh which contains the supernode. So in this way we will be getting back those two equations which we have lost due to the presence of supernode. So I hope you have understood this, and we can solve numericals which contain a supernode like this. So thank you for joining.